In this video, we're going to be learning about normal distribution. If a set of results are normally distributed, we would expect the vast majority of the results to lie around the mean. We would expect that 68% of all the values to lie within one standard deviation from that mean. We would expect roughly 95% to lie within two standard deviations of the mean, and then 99.7 within 3 standard deviations of the mean. When working with variables that are normally distributed, we encode them, where on my x-axis we have our z-score and we still have our normal distribution. The vertical axis in this case is at 0, our new encoded mean score, and the area that lies underneath the graph up to a particular point is the probability of getting that particular value. In order to code a variable, we use the formula that z is equal to x minus the mean, all divided by the standard deviation. Looking at the notation that I've been given in the question, I can see that it matches very similarly the example on the left-hand side, that the mean is 173, and although the variance is 2 squared, the standard deviation is 2. The variable value in this case is 177, so I can work out the z value, which is 177 take away 173, all divided by the standard deviation, which is 2, and this gives me a value of 2. I now need to work out what the probability of z being less than 2 is. And to do this, I use our normal distribution table. From the table, I can see that for a z value, which is 2.00, the probability, the area underneath the graph, is 0.97725. This is the final answer to this question. You'll notice that looking at the table, I can only calculate positive values of z. So what if z had been negative? So let's have a look at the question where I'm after the probability that x is less than 171. Now this is going to create a z value which is negative simply because I've chosen a number to the left of the mean. So if I now calculate the z-score, z will equal 171 take away 173, all divided by 2, and the numerator will give me negative 2 divided by 2 is negative 1. So I'm now after the probability where z is less than negative 1. Now sketching a quick normal distribution graph. Where there will be symmetry around the y-axis, which is at 0, negative 1 will be about here. To answer the question, I need to calculate the area represented by this shaded region. However, if I can only read positive values of z, I need to think of how else I can calculate this area. The area that I've highlighted will be exactly the same as the area that's on the other side, at 1, except when we use the normal distribution probability tables, it calculates the area from the left up to a given point. So we need to know that the area underneath the entire normal distribution adds up to 1. And if I calculate the area up to 1, I can take it away from 1 and it will give me the remaining red area. So looking at the probability table, the probability of a z-score of 1 is 0.84134. So therefore the probability of z being less than negative 1 will be 1 minus this value. And this would be my final answer. Pause the video here and have a go at the question on the right hand side. When you're ready for the answer, press play. The first thing I need to do with this question is identify the 3 values that I need to code up this question. The x will equal 184, the mean is 187, and the variance is 1.44, so therefore the standard deviation will be the square root of it, which is 1.2. Now coding the question, z will equal 184 minus 187, all divided by 1.2. This gives negative 3 divided by 1.2, which is minus 2.5. Now drawing a quick sketch of a normal distribution, we can see that negative 2.5 is on the left-hand side, and this will share exactly the same area as that above 2.5. So, using the same fact as what we discussed in the middle, if I can calculate the area shaded in green and take it away from 1, this will then give me the area remaining, this section here. As a result, this area, due to symmetry, will be the same as this. So the probability that z is less than 2.5 is equal to 0.99379. That means that the probability that z would be less than negative 2.5 will be 1 minus this value. So 0.00621. And this is the final answer to this question.